Hello and welcome to today's CPD session. This webinar will provide a guide and a reference point as we progress through the content, and you can find it in the handout section of the Go Control webinar control panel. We do encourage questions, so please use the question box to share any you do have. This session is a mixture of providing information, exploring best practice, asking questions and sharing ideas. Therefore, it's vital that everybody participates fully, sharing their ideas in a collaborative way to allow for peer learning to take place. We're going to use the range of interactive activities today, so please have a smartphone or tablet ready if you have access to one, and we'll use web links too, so don't worry if you don't, you'll still be able to participate. If you haven't already done so, just please let me know that you can hear okay by popping something into the question box, which you will find in the control panel on the right hand side of your screen. I'm Rachel Webster, part of the provider development team. A little about my background: I have teaching and assessing experience from a range of settings, including schools, colleges and private training organisations, teaching mainly IT qualifications and apprenticeship standards from pre-level to level 4. And we are also joined today by our subject specialist, David Seddon, who will bring in his industry and subject specialist knowledge throughout today's session. Hi, David. Thanks for joining us today.
Hey, Rachel. Yeah, everybody. I'm Dave Seddon, as Rachel said, and I'm the digital subject specialist at NCFE. I'll be covering some of the technical content when we go through it in today's session. Just a bit about me. I've worked in education for over 20 years, and in that time I've taught and managed computing curriculum both in further education and higher education. I've been involved in the development of things like the digital degree apprenticeships, as well as supporting with the development of the digital T-levels and also higher technical qualifications. So for me, this technical and professional qualifications, I think these are what we need to provide students with that reliable, valid and the current skills that's needed for working in the sector.
Thank you, David. You'll now see the objectives for today's session on the screen now. The session will last approximately about an hour, and it is being recorded to allow all relevant colleagues to access it. So root core element 3 covers the characteristics of data and data visualization, and I'm sure as we go through the session today, it will become relevant and hopefully provide guidance to support you with your delivery. Therefore, we're going to structure the input of today's session on the basis that you're experienced practitioners. So I'm going to start off by asking if everybody could respond to the first poll question, which is: how challenging is it teaching the T-level in relation to characteristics of data and data visualization? So I will launch the poll now. And I will give you all a few moments just to answer. Nearly there, I'll just give a couple more moments. I can see the votes coming through. Okay, I think we're there now. And actually, it's a 50-50. We've got 50% saying moderately challenging and 50% saying they find it quite challenging. So I hope today's session will help and support you with that. So as we know, data can be stored in a range of different formats and structures to ensure that the stored data is organised and accessible for the end users. So if we start off with a quick question: what are some of the common data types? If you could please use the question box and to put your answers in. So what are some of the common data types? Yes, somebody's put text. Yeah. Integers. Absolutely, yeah. We've got media coming in. Anything else? David, would you like to add anything before I move on?
Yeah, I mean, I think the key thing is, data's it's all about information, how we store it, how it's used by companies, and it's becoming like gold dust. It's there to drive the business goals and the business strategies. And I think it's getting across the accuracy of data and um, how important this is in how we present findings through visualization. So making students aware of problems that can occur if it's not recorded well, if it's not stored or managed accurately. Um, and the security of data meeting legislation needs. We need to think about meeting the needs of the audience and whether that's either organizational needs or whether it's individual needs. And I think it is that making sure it's controlled right and making sure we manage it in line with legislation.
Yeah, sure. Thanks. So the most common data types outlined in the specifications are on the screen now. So you've got your numeric data, things like integer, decimals, and currency. Your text, such as characters, words, paragraphs. Media data, it's represented either visually or in an audio format. And this includes images, sounds, and videos. Geospatial data and objects, events, or phenomena that have a location on the surface of the Earth. We've got temporal data, what represents a moment in time, and usually shown with a date or a timestamp of duration. And then logical data that has two states or choices. And this type of data is also known as Boolean data. Now, I know you like to consider the sources of data both internally and externally and how your students might relate to it. So if you have or about to deliver this root core element to your students, you'll have knowledge about the internal and external data sources. So instead, I would like to look at a video game scenario that you could introduce to your students as a way of engaging them in the topic. So before I do, I would like you to consider some factors on the impact on data based on the Mario Kart game. So has anybody played the game Mario Kart? I know David, you and your family used to play this quite a lot. But what made the best player? Was it the expertise? Was it the character they played? Or was it the kart and a combination of the tyres? What made the ultimate combination? Now I'm going to put a link to a Jamboard into the question box. And just please use it, and you'll be on the first slide, and add a sticky note to answer the question. I'm just going to launch it open myself. So what made the ultimate combination? And what would the impact be on the data? So I've added a 1 just to get us started. So I've just put on an expert player. Yep, number of coins collected, absolutely. Any other ideas? the court itself, and weapons, yeah. Any other ideas what's not already shown on the slide? David, would you like to add anything? Can you think of anything we could put on here?
Yes, I suppose it depends which side we look at it. You know, from a player's perspective, we could be looking at the expertise of the player. It could be looking at the age of the player.
Yeah,
We could be working with, is it on a platform they're familiar with? You know, they might be playing it on the Switch, but they've never played it on that type of system before. It could even be down to the fact that they're used to playing it and they always use a steering wheel, but in this case, they're given just a normal controller. And then
yeah,
from a game perspective, it could be anything to do with the characters, the weapons,
yeah,
the way they kit the cars up. So I suppose there's plenty of different variables that could be coming into consideration there.
yeah. Absolutely, thank you. And if I can just ask everybody to keep this page open because we will be coming back to it a little bit later on. And thank you for your participation as well. So let's start by looking at the internal data, or in our gaming scenario, the game player. So we could consider the gender of the player. Would that make a difference? The age of the player? And how much experience the player has of the game? Is it the player's first time? And then how much experience in playing games overall does that player have? Would that make a difference? And then we have the external data. So the character's data would include things like the weight, the speed, acceleration, and the handling. The most obvious trend here is the trade-off between speed and acceleration. So heavy characters have a good speed but poor acceleration, while light characters have snappy acceleration but a low top speed. And then we have the carts and tires, and each of these have their own statistics. So the cart statistics could include the weight, speed, acceleration, and handling. And the tires could include the weight, speed, acceleration, and handling also. David, would you like to add anything before I move on?
Yeah, I know with this game, I mean, we used to play it a lot as a family. You know, it was always a battle to see what character you get. I think I always chose Mario because he was the main character, not because of his speed or the way it played. It was just familiarity. But I know when the kids played it, they always approached it from a different angle. They'd always look at which character worked best and what was the best cart to choose. And they'd always want to know what racetrack we were going to play on because they wanted to choose the best combination to suit that track. So really, you wouldn't think quite a family game like this could be quite so strategic. And I suppose then you've got all your variables in there as well. You know, what weapons you might pick up, or even if you miss a weapon, what's the impact if you get hit by that weapon, which we might not be able to account for if we was doing analytics. So, you know, somebody might fire a shell just before you're about to hit the finish line, which I know I've been in loads of times where I'm about to come in first, suddenly not back to sixth place. So it's something that makes it quite challenging when we're trying to use analytics to calculate something out.
Absolutely, thank you. So in case you're interested, one data scientist identified the following as the top optimal configurations based on the statistics. I'm going to put the link into the chat box just in case anybody wants to read up on it in a little bit more detail. I'll pop that in now. Okay, if we can now refer back to the Jamboard, and if we can go on to frame 2 or slide 2 for the next activity, and you'll find the link in the chat still if you close the page by mistake, or just let me know if you need it. I would like you to post some ideas about the types of student data that could help identify the best player. So that's what we're looking at on this next page. So what student data could help identify the best player? Experience, absolutely, yeah. Anything else? Yep. If the player is either tired or ill when they're playing, that is going to have an effect. Yep. Time of day. They mightn't be a morning person, so they mightn't be playing the best in the morning as they would on the night time, or the reverse. They mightn't be very good playing during the night if they're used to being asleep. Yep, the type of game used to playing. Yep, so it comes down to the use of playing the game, how often do they play it, or they're new to the game, it'll have a massive difference. So again, just keep this web page open because we will be coming back to it a little bit later on. We've just got one more coming through, and we've got the controller and the platform they're using, or they're used to that system, or they're used to the control. Yep, that'll have an impact as well.
Yeah, I know. We used to do this a lot with degree students at the college I worked at. While we was preparing them for things like dissertation and doing the data analysis inside that. And I think it's amazing sometimes some of the things that students highlight. You know, we had things like time of day coming up because some of them would say, "Well, I'm used to playing at night, but I'm not really in the right mood in the morning when I'm playing." We had things like the controller, or I'm always used to using a wheel, or oh, I don't usually play that track, I play something else, or I've not played it on that platform before. So it's quite surprising sometimes some of the things that, you know, if you're doing this with students, some of the things that come up that maybe you hadn't thought of could impact on the game.
Absolutely, yeah. So what's the point behind all of this? So you could ask your students to work out some of the previous examples, what we've just collated on the Jamboard, based on a scenario you've given them. So if your students can identify the purpose of the data gathering, then they might start to see the real benefits of data collection, measuring and analysing, and the ways it can be used to answer relevant questions and evaluate the outcomes. And for this gaming scenario, the ways they can use data to help them win a game. So ask your students to record all the relevant information they think they'll need about the class. This could be, but not limited to, the gender, the age, the experience in playing the Mario Kart game, and experience of gaming in general. But they might record other information such as how often they play the games, the time of day they play, the days of the week, and then lap versus race versus challenge. But there's
Yeah,
probably lots of other stuff.
yeah, I think one of the key things here is, it's all about it being data that the students are familiar with and things that they can relate to. Um, and the purpose behind this is really letting the students record as much data as they can at this stage, because if we're collecting the data first and they don't know what they're going to be doing with that data, they might decide some of what they've collected becomes relevant later if they start changing their analytics, or it might find that we've got things in there we don't need and we can start discussing, well, what's the purpose of capturing that data if it's not having an impact? So the more data we've got at that stage, the easier it is to start changing results based on little tweaks or patterns. Um, so, for example, where we'd said about sleep patterns, it might not seem relevant straight away, but if you had all the students playing the game in the morning and then on a different day in the afternoon, you might find that you're getting different results just based on the time of day that you're doing it, or even just the fact it's on a different day. So it's remembering all the data that you collect, and it's all their data. It's all about them. And then your students need to think about what other data they can record from the game itself. And that could be things to do with the cart that they're using, the bike, or if they use a bike instead of a cart, it could be the tyres they put on it. The glider they put on might have an impact. And again, that'll be depending on the track they're choosing. And how are they going to record their information? Are they doing it based on the time it takes to finish just one lap? And are they recording the fastest time and the slowest time so that they can see where it varies between it? Or are they doing it based on a complete game or 3 laps, something like that? And again, the fastest and the slowest time so that they can work out an average. And at that point, it's then letting them start to think about how they could record weapons. And and this is where the task undo starts to grow quite big, because you've got so many variables with it. What if a player doesn't pick up a weapon? What if they pick one up, but it's not a weapon that they can use at that time? Is it a weapon that only impacts on one player? So if they pick up something where they can just affect the person winning because of the shell they've picked up, or dirt on the screen if they hit somebody, or is it something that affects multiple players? So they throw a shell and it knocks 10 people down. So it's all about how all that data can change and adapt based on what they're doing, and get the students to play the game and record all the results. And you might find if students are recording the results in different groups, they're all recording slightly different data and ways of combining that data together.
Yeah, thank you. So at this stage, we'll have all the data and we need to identify the best player. So, for example, who completed the last lap the fastest, but what were the variables? Would that person be the best if they've used a different character, a different cart, tyres, etc.? You could have lots of fun adapting the data to change the outcomes, then ask the students to make up an infographic or use a visualization software to make a dashboard.
Yeah, and at that point, you can get the students to look at the data they collected and start to think about, well, is everything they've got irrelevant, or is it relevant? Is it structured, unstructured data? If they removed anything, does it make a difference to the findings? For example, we'd said earlier on something about, do we need to know gender? Well, unless we're going to break the analysis down into are girls better player than boys? Well, no, we probably don't. So why are we recording it? So again, it starts thinking about what the relevance of the data is that they're gathering. And using a scenario like this, it's fun. It opens up so much scope for manipulation. And the good thing about it is that it, it gets across to students how important data is to get across a picture or how data paints an accurate picture. So students can start to see if they tweak it slightly, suddenly somebody who shows as the best player based on one set of data, by just making a few amendments, suddenly changes the whole aspect or the ratio of everything. For me, it's all about using data that's relevant to the students. If they understand the purpose of the data, then it's easier to get them to understand what we're trying to gain from that. And if you don't want to play games or you don't want to be stuck down that, there's loads of different data sets out there. The UK data services have got created data sets that they use for teaching purposes. So they're all accessible. You can download them. I think we've got a link to it if Rachel can put it in the chat for you. And you can always have a look there, and there's different data sets you can use. So it saves you going out and finding those data sets or making the data sets up.
So while looking at storage options, it's easy to explore them individually, but consider how many students will already have experience of storing data on drives, thumb drives, external drives, and cloud-based systems such as the game saves stored on cloud-based gaming solutions, game saved to thumb drives, external drives used with gaming platforms. You've got the phones when they're saving photos to the cloud. That could be Google or iCloud, for example. And phones are backed up to the cloud. Emails saved to the cloud. Documents saved to OneDrive, iCloud, and Google Drive. And more applications are saving data online. Some games are saving their full days online. So before moving on, David would like to share some global cloud computing statistics with you from TechJury.
I mean, as cloud storage is becoming more popular and it's becoming the most popular mechanism for storing data, I just thought it'd be nice to share some statistics to kind of see how it's growing. We've already said it's being used now for things like gaming and storing data that way. I know businesses are using it now for storing all the data. So the information that I've got on this slide just comes from one source, TechJury. And I thought if we use statistics here, at least it shows how we can use statistics from one aspect or one area of computing for students to relate to and show the importance of it. So all this comes from TechJury, which the link will be in the chat in a minute. But from there, you can then drill down to where all these articles came from. So some of the points on there, we can see that 81% of enterprises have a multi-cloud strategy that's already set out or it's already in the works. We've got 67% of enterprise architecture, which is now already cloud-based. And from that, there's an additional 82% of the workload that will reside in the cloud. There's more than 40 zettabytes of data that will be flowing through cloud servers and networks. And this was based on 2020 cloud forecast, where it was anticipating that there'd be around 5,200 gig of data for every person on Earth, which equates to that 40 zettabytes. The average person uses around about 36 cloud-based services every single day. And Amazon Web Services is now the largest cloud computing market share at 32%. And platform as a service has grown in adoption rate, and I think it's gone up to 56% in 2022 and still growing. And just to conclude with a few more key facts, data shows that in the last decade, cloud computing's grown from 24.65 billion in 2010, and has already, as of last year, had already surpassed the $150 billion mark. The most popular free cloud storage services are iCloud and Dropbox, with just over 300 million users per platform. And the three sectors that plan to spend the most money on cloud computing services are manufacturing at around about $20 billion, professional services at around about 18 billion, and banking at just short of $17 billion. The positive impact of cloud technology is almost instantaneous, and 80% of companies have reported operational improvements within the first few months of adopting the technology. And finally, cloud computing jobs have increased by 42% in the last 3 years. Thanks, Rachel.
Thank you. So now I would like to move away from the gaming theme and try something a little different. So we were thinking about a database to store friends' details, like a personal phone book, to bring in validation. But firstly, I would like to get you to complete another Jamboard activity. And if you can refer to frame 3 or slide 3 at this time and post your ideas on the board. And I'll just bring the board up. So what kind of data could we get students to record about themselves so they could arrange themselves into a human database? Absolutely. First name, last name, their address, phone number and email address, absolutely. The age, yeah. Date of birth. Qualifications and grades. Their interests, good one. Anything else you can think of what's not currently on the board? I'm trying to think. I think these have covered most of the ones I thought. David, can you think of anything else? Best subjects come up.
Yeah, I suppose it's vast, isn't it? You know, you could have like a TV show, best game, you can have hobbies, interests, best friend.
Yep.
I suppose it's endless where you went with it. You could have them
Yep.
collecting as much data as you wanted.
Absolutely. So an activity idea you could do with your class could be to ask your students to put their name, date of birth, and maybe the favourite game or TV show onto a piece of paper. You could split the class into 2 groups, and the first challenge could be for the groups to sort themselves in order based on the following. So it could be their first name, A to Z, the last name, Z to A, youngest to oldest, favourite game or TV show alphabetically. And once the groups have organised, they need to shout out so you know which is the first and you can check for accuracy. And this introduces them to the human database. What did they do or would they do if 2 people had the same name or the TV show, for example? This starts to look at problems that can or could occur with sorting. We'll now ask the students to list things they would need for a phone book, and the more the better, but should include at least the following. So the name, address, and the mobile number. And for the purpose of this, let's assume that also like games. If you really don't like games, use a TV show. So you could have like the favourite game or TV show, and we can then explore how this would work in a flat database and explore the attributes, the data type, and the information that would need validation. So for example, they could store the first name, address, favourite games, and mobile number.
Yeah, and I think at that stage, I'm sure a lot of the students will have several favourite games or several TV shows that they like. So at this point, you could ask them to have only one value in a cell, and then from that we could then start to look at primary and composite keys and making the records unique. So how would we do that? So we'd start to then take them to first normal form at that stage, and we can then look at, well, how could we partition the table out so that friends in one table and then another table holding maybe the games, and then introduce them to the concept of a foreign key. So we're then starting to take them through to second normal form with it. And then we could look at what if you've got two friends with the same name, or twins living at the same house with the same home phone number. So we could now explore third normal form and relational databases. I know there's a lot more to it than that, but this concept. It's something that students really struggle with when we kind of run through it as a process on the board and talk about it. But again, if we're doing this as a bit of an activity where we're getting them talking, getting to think about how they're organising, and it's all data that's relevant to them, information they know and they understand, sometimes it's that little easier for them to relate to, and it makes the process of kind of teaching it a bit easier. What if we want to be able to call anybody in the phone book that lives within a 1 mile radius? Could we do it? Well, if we couldn't, we could then get them to add, add to the database so that we could do that. And from that stage, we could then think about how we'd query the database to work with it. So kind of giving them a brief introduction to SQL with not going into the coding, but how the queries work. And again, if anybody isn't too comfortable just going into SQL at that stage, Rachel will just put a link into the chat for a YouTube video that gives a very brief introduction into SQL and looks at things like select, where, order, inner join, group by, and having. Again, apologies, it uses gaming again, but it's using a FIFA data set to get the point across. It's only it's about a 12, 13-minute video. And from that, there's always also a follow-up video that goes through working with tables and things like that. So the two videos in total give a really good introduction to SQL and how it's used.
Thanks, David. I'll just put the links into the chat if anybody would like to access them. So when it comes to presenting data, spreadsheets and reports full of text aren't enough to explain what we found. And this is when we need data visualization to present the data in a way that helps everybody grasp different concepts. So I'm sure that everybody has their own favorite tools for this. And we can obviously use Excel or equivalent to put together a visual presentation. And we can even use some form of tools in Word and PowerPoint to make things look nice, but these are probably not the best as it's not the main purpose. So for centres that are invested in Microsoft 365, you may have Power BI. This is a cloud-based business intelligence service suite that's used to convert raw data into meaningful information using intuitive dashboards. Obviously, one key advantage is that it works well with Excel, and you can import data into it from a wide range of different sources. So having said that, it's not without its flaws, and many find the interface a little bulky with limited configuration and optimization properties.
Yeah, and if you don't have access to that, another option that's out there is Tableau, and you can get a 12-month free license for students working with that. And if you go to the site and you have a look at it, they recommend using Tableau with students to do things like an analysis of their assessment results or creating visualization on topics they like. There's a fantastic one on there on the Marvel Cinematic Universe that really kind of gets the impact of data and how it works visually with all the characters in there, so that if they click on one character, they can see how it's interacted with other Marvel characters and where it's coming from. So it's a really good way of demonstrating it across. I think there's an example of it on the screen. Oh, they can. There's one example where they use it for monitoring their own e-learning. So they focus on getting students again to use data that they're familiar with and that they use on an everyday basis to then kind of illustrate why it's important to get that visual insight across and the difference it makes when you're using visualization. There's also different free tools out there that you can use. And I know it's not always easy getting it installed on a college or a sixth form network. So there's online tools that can be used at the same point as well. So I'm just going to concentrate on a couple of online tools that you might be able to use. First of all is Data Wrapper. Data Wrapper lets you create charts from, I think they've got about 19 different styles of maps and tables in there. It's quite easy to use, great for doing visualization. So if they just want to pull some charts and that together for putting in a report or a presentation. The only drawback is you can only export your graphs then as a PNG file if you're using the free version. We've then got chart blocks. Again, this is an easy to use chart builder. So you can build the charts up in, it takes a few minutes to put a chart together. Excuse me. And some of the types of charts that are available are things like bar, line, scatter charts, and pie diagrams. And the good thing about this is with a lot of these free online software, when students put data in there, the data automatically becomes public. The nice thing about this is a lot of the charts you create, the charts are private, and a lot of the limitations you normally get with free software, it's a lot better with chart blocks, what you do get. Then we have Infogram, which lets you create infographics and reports easily. You can add animation to the infographics. You do have a restriction in the amount you can create. I think it's around about 10 projects you can do. And as I mentioned before with some of the others, any data you put in there becomes public data. Then we've got Flourish, and Flourish lets you create charts, maps, and stories. Again, it's easy to use. There's loads of templates in there that you can play around with. With the free version, though, you can't keep your data and projects private. Again, it's public. So it's something that you need to make students aware of before they start putting any information into any of these. And there's plenty of other options out there as well. You know, there's Chart Studio, Night Lab, Tableau do a tablet public version that you can use. And no doubt many of you might have come across something like Canva. Canva's fantastic for doing things like mind maps and infographics. And finally, there's Raw Graphs. Raw Graphs is good because you don't have to sign up to anything. So all you do is you add your data and you go. The problem with it, it's a little harder to get familiar with. It's a lot harder to set up and configure it. So if you're going to use that with students, I'd recommend you have a play around with it first, just to familiarize yourself. You know, the main thing is whichever of these you're using, just test it, make sure it works with the type of data. Make sure students know that in most cases, these free accounts do result in any data they upload becoming public data. So make sure they only use sample data when they're doing it. And finally, in most of these, there's a requirement for students to create accounts on many of these sites, which some of them might not want to. I was recently at a conference, and that one of the points he was making was, you know, should we be making students sign up and put their free data, put their information out there into these systems where we're signing up? So obviously, if they've got to put their data in, that should be optional.
And if you want to let students know about the different charts and visuals they can use, take a look at the datavizproject.com. They can look through different visual charts and diagrams. You can select any of these to get a more detailed breakdown of what it is, such as pictorial. And then from there, you can choose the input data on the right-hand side of your screen, which lets you see other charts that would display the same kind of data. And it's really a nice way to explore all the options available and to familiarise yourself with the different chart styles you can use for particular data sets.
Yeah, I think the key thing here is, it's making sure students are aware that there's different ways of displaying data, and some ways are better than others. We know bar charts are a good way of providing a representation of categorical data, grouping data together into groups such as months, years, age group, shoe size, that type of thing. We know picture graphs use relative size or repetition of the same icon or picture to get that information across, and curved bar charts, seen in modern infographics, sometimes criticised a bit for being a bit confusing and inaccurate compared to a normal chart. But again, different options that are out there, and it's all about deciding what's the best format for displaying the information so that the stakeholders who are watching the presentation or reading the report or whatever it's in easily recognise and understand the information they're getting across. For example, would the information be better suited to a tabular format like a table, which everybody's used to? It's used in all types of communication, research, analysis. It's something we're familiar with, but then on the downside, it's not visual, so it's not as easy to just get an instant picture of something that's happened. So it's about making sure the students understand what's the best way to display data to get across the message that they need to for the type of stakeholder they're working with.
Yeah, absolutely. We are reaching the question and answer section. If you do have any questions, please do ask us. I would like to also refer you back to the Jamboard to complete the final frame and add one key takeaway from today's session. And I'll just bring that up onto the screen now. And if you do have any questions, please add them to the question box. So one key takeaway from today's session. And I'd just like to remind you as well that you will find a PDF copy of today's presentation slides in the handout section of the webinar control panel. So if you want to download them before the webinar finishes, so you can have access to the links which have been shared as well. Yep, somebody said use the data chart site. Absolutely recommend you do have a look into those and visualize and marvel. It's really good. The visualization tools, yeah. Yep, having a look at the gaming data. Your class might find that quite an interesting way of getting into a reason behind why they're collecting the data and analysing it. Yes, definitely the human database, give it a go. Online tools, yep. Just have a look at them, investigate them, see what would work, see if the use your data, what you've got, or you can upload your data, just check it out before you introduce them. Now, I'm just going to launch our final poll question. So after attending this session, how has your confidence level changed in relation to your starting points and in relation to data overall? I'll just give you all a few moments just to put your answers in. And it looks like they've all come through, and it's really, really good to see that everybody is at 100%, so that they feel as if they've extremely improved after today's session. So that's really good to know. If you do have any questions, please do stop on and put some into the question box. And if not, we'd just like to say goodbye and thank you all so much for attending and participating in today's CPD session. Please do take a minute as you do log out to complete our evaluation form. Your feedback and ideas help us to develop our CPD offer, so please do take a couple of minutes just to complete that for us. We would appreciate it. And goodbye. And from everybody at NCFE, please stay safe, and we do look forward to working with you again very soon. Thank you.